Okay, I'm going to talk to you guys about ocean tides and how the gravitational pull of the moon affects that high and low tide. About every 12 and a half hours, you're going to have a rise and fall of the ocean water, um, creating a high tide on the rise and a low tide on the fall. The water's going to rise for about 6 hours, and then it's going to fall for about 6 hours, and so that's where that 12 hours comes from in terms of that full cycle. It's really about 12 and a half, because you have a point to where obviously it basically there's no more rise and there's no fall either. That 0 point, while it's in between those two. This is going to happen because gravity is going to pull the moon and the earth towards one another. And so that gravitational pull is also going to affect the water on the Earth's surface, causing these tides. Tides are caused mainly by the difference in how much the moon's gravity pulls on different parts of the Earth. The point at which the moon is closer to the Earth is going to pull the water toward that side of the Earth, causing the water to rise, and it results in high tides. So if I take a look at this, what ends up happening here is that if the moon is on this side of the Earth right here, okay, there's a gravitational pull pulling the water in this direction on the Earth. So the result of it would be a high tide over here, because again, it's creating a stronger pull on the water. So, and because the water on this left side of the Earth right here is the closest point to the moon, that's where you're getting that strongest gravitational pull. Now, the reason that's important to understand is because if we look at that same situation, when we look at on the opposite side of the moon, the force is weaker, obviously on the side away from the moon than it is on the same side as the moon. But that's going to also cause a high tide on the other side. So basically what we're looking at is high tides on opposite sides of the Earth. So let's go back one slide and take a look. So here, because the moon is on this side, we have a high tide over here. But directly across from that side of the moon, or that side of the Earth opposite of the moon, the opposite side is also going to have a high tide. Okay, so I have a high tide over here on the near side of the Earth, and a high tide directly opposite over here. So you have two high tides at any one point. The reason for that is because in this situation here, where this side of the Earth is closest to the moon, it has a stronger gravitational pull right here, correct? Well, if we also look at the fact that the center of the Earth is closer than the far side of the Earth over here, this results in a weak situation, in a weak tide on this side. I'm sorry, a weak pull, weak gravity. Okay, so we have weak gravity over here. What happens then is this results on water being left behind on this side of the Earth. So you have water left behind on this side, okay, I'll put LB, left behind, and we have water on this side of the Earth because of water being pulled. So I'll put water's being pulled, right, WP, water's pulled. I want to look at this a little bit better. Okay, water's pulled over here, and over here, water's left behind. Okay. So it's these two phenomenons, the water being pulled and the water being left behind, that's going to cause the high tides at opposite sides of the Earth. Okay. get rid of this. So let's look at the next slide. So the result again is that there's two places on the earth with a high tide at any one given time, and two places on the earth with a low tide at any one given time. As the earth rotates, one high tide stays on one side of the side of the earth facing the moon, and the second high tide stays on the opposite side of the earth. Each location on earth sweeps through two high tides and two low tides in a 24-hour period, or 25-hour period. So you can if you notice again, if I look at my 2 points of high tide here, and my high tide here, okay, and let's just say, let's pretend that the moon is over here. Let's put a moon right here, okay, and this is going to be the moon. So the result of that, again, is that you have a high tide over here on the left, right, over here, close to the earth from the water being pulled, and you have a high tide on the opposite side of the earth from the water being left behind. And then at 90-degree angles, you're going to find your low tide, because if it's high somewhere, it has to be low somewhere else. So then this is going to be that situation, okay? But as the moon rotates around the earth, okay, as the moon goes over here, well, then we have a shifting of the tides. Okay? In that situation, if that happened, then we would end up with a high tide over here, and then opposite the moon, you'd have a high tide over here. And then at 90-degree angles would be the low moon, or the low tide rather, and again the low tide. If the earth, or I'm sorry, when the moon rotates as it moves over to here, then once again we end up with a high tide on this side and a high tide on the opposite side, and then we end up with a low tide at the 90-degree angles. Okay, so hopefully you kind of see how that works. Now the results, this is the same slide, so we'll just skip over this. We then have a spring tide, and in the spring tide during the new moon, the sun, the moon, and the earth are nearly in line. The gravity of the sun and the moon pull in the same direction. Their combined forces are going to cause the tides with the greatest difference between the consecutive low tides. And so what we're saying here then is that it's always strongest. If we take a look at this, we have the sun, okay, and then next in line is the moon, and then last in line is the earth. So then what you have here is you have the gravity of the moon, or I'm sorry, the gravity of the sun plus the gravity of the moon equaling the tides. And so you obviously have an increased gravitational pull. That results in the highest tides of the year of the month, highest tide of the month and the lowest tide of the month. And remember, the reason that this happens during the new moon is because the new moon is the time in which the moon is in between, or I shouldn't say in between, but is on the same side, rather, of the earth as sun, right? So if my moon is sitting right here, the new moon, remember, it's being lit up on the left side. But if it's over here, I have a full moon, right? Well, in this situation, you're not going to have the sun plus the moon. So it only happens during a new moon. That's when you're going to have your spring tide. And let's see. The last one is we're going to talk about neap tides. Now, neap tides are during the moon's first quarter and third quarter phase. The lines between the Earth and the Sun are at right angles to the line between the Earth and the Moon. The sun's pull is at its right angle to the Moon's pull. This arrangement is known as the neap tide. The reason you still have this is because we talked about gravitational pull, and because the moon is so much closer to the Earth, its gravitational pull on the Earth affects the tides more so than that of the sun. But nevertheless, I still have, keep in mind, if the moon is on this side over here of the Earth, then we're going to have a high tide over here, right? And then we're going to have a high tide on the opposite side. Let's pretend for a minute let's get rid of this moon for a second. Just for visual purposes, right? Let's say there's no moon right here. Let me get rid of it. Okay? So if I had this situation and I had the moon where it is, then the high tide, since the moon is on, the bottom side as far as this illustration goes down here, then I'm going to have a high tide. And then I'm going to have, again, my high tide on the opposite side. But because I also have a gravitational pull between the sun and the Earth, it's going to affect this high tide. But again, that pull isn't so strong that it isn't going to, it's not going to stop a high tide. It's just going to make that variance a little bit different. And we'll talk a little bit more about that in class. But again, it's going to make that variance a little bit different. And remember, the quarter moon is going to be over here on this side of the Earth once a month. But then, during the other part of the month, it's going to be on that side of the Earth. And so again, you're going to have a high tide on one side and a high tide on the opposite side. Again, these are the neap tides. They occur twice a month during the quarter moons, unlike the spring tides that are only going to occur once a month during the new moon. And we'll discuss this a little bit more in class.